Okay, we are going to do a quick review on rules of fraction. Because you're going to need this as we are doing multiplying fractions. So you need to understand how to do your fraction operations, guys. So we give you a quick rule sheet. Let's fill in. Help keep you engaged as we're going through this. So you're going to need to fill in the pieces as we're talking. But you can now use this sheet for all of your work on today and anytime you're doing fractions. If you're having questions, you can pull this sheet out. So the first thing you should do is put your name on your rule sheet. Put your name on the packet. Okay, we're going to put it on top of both of those. Our first rule for adding and subtracting fractions. All fractions must have what? What is our key for adding and subtracting?
Common
denominator. So they must have a common denominator. Our key on that one is anything I do to the denominator to get them the same, you must do to the top. So you must also do to the top. We have to keep them equal for the numerator. Use the correct math terms here. Okay? Once fractions have a common denominator, you only do the operation, addition or subtraction, to the top or the numerator. This is on your rule sheet. Did you not get one either? Okay. So the next one is we will always simplify. So you must always simplify. Apparently.
Sorry.
It's okay. We got it. Multiplying fractions. Guys, this is the easiest operation. Multiplying is super easy. I'm going to add a step to try to help make it easier for you. Look for common factors on top and bottom. Key there, your 14 numbers, 2, 3, 5, 7. Look for places where I can reduce the top and the bottom. Got a common factor, I can pull it out of both of them to make the math easier. Okay? So, and to reduce is the term we're using. I'm going to try to reduce those if I can. If you do this step, it will give you the answer in simplest form. If you choose to ignore this step, you prefer to do it Mr. Chan's way, that just means after you multiply the numerators, you guys can't see her face when I said her name on that one, and then the denominators.
Are you trying to make up for you saying one thing that I was out?
Yes.
Okay.
I missed you.
No.
Okay, and then number 3, you have to simplify, especially if you do Mr. Chan's way. If you do the reductions, you're simplifying. The most you'd have to do is turn it into a mixed number. Okay? Dividing fractions. We can't really divide fractions. We had a whole discussion on this, right? Mathematically, it doesn't make sense to take parts of the number away, just like we can't divide by decimal. So we have to do our first step here. We need to rewrite the fraction so you multiply by the inverse. The steps are easy. It's keep the first number, change the division sign, and I apologize, typo, cross out that second division sign. So change the division sign to multiplication, and then flip the second number to its inverse. At this point, we now treat it like multiplication, including looking for reductions. Key note on that, you cannot reduce a division problem. So for those of you that understand how to do reductions and make your life easy, it only works in multiplication. You can't do it in division because that will give you the wrong answer. Once again, your last step is simplifying if needed. Any questions on the front page?
No, sir.
Okay, so let's go to our second page. We haven't done as much with this yet this year, but for adding and subtracting our mixed numbers, we're going to give you 2 options. I prefer option 1, Mr. Chance prefers option 2. And I'll be honest and forthright, option 2 is going to work better in more advanced math, but option 1 is a lot easier for our level. So I'm going to give an example problem with this one to help make it more understandable what we're doing. So we're going to work with the problem 4 1/3 minus 1 2/3. So write that one down on your paper as well. I gave you plenty of space in there for a reason. The first thing we do is take out the fractions first and follow the rules for adding and subtracting. In other words, I'm just going to pull this fraction piece out first. 1/3 minus 2/3. Okay? Quick side step, just to help you understand why we're doing what we're doing. If I take a number, say 23 minus 18, can I do 3 minus 8? No, so what do I need to do? Go to take 2, take away 1, which is actually I'm borrowing how much?
Yeah.
I'm borrowing from the tens place. I'm actually borrowing 10, right? So I add 10 to the 1 and I make this 13, right?
Yeah.
So, is everybody okay with that? I hope so, because this study is up what we're going to do next. So 13 minus 8, 5, 1 minus 1 is 0. So my answer is 5. Everybody okay with that? Okay, because here's your key concept. If subtracting and my second numerator is bigger than the first, I'm going to need to borrow from the first whole number to make the first numerator larger. Because I cannot do 1 minus 2. We do not have a commutative property of subtraction. I can't just flip it and say 2 minus 1. Cannot do that. Okay? So I am going to borrow, just like we did here, the amount of the denominator. So another quick side step. Here, how much did I borrow? We borrowed 10. Now I'm borrowing from this number, correct? So the 4, I'm making a 3. How much did I just borrow? No. 1. I just borrowed 1. Is everybody okay with that? Because I went from 4 to 3. I borrowed 1. Here's where the difference is. Because I am working with fractions, can I make that 1 12 12?
Yeah.
Why not?
You can.
Why can't I make it 12 12? I can, right? Why not? What's 12 over 12? 1. Could I make it 4 4? Could I make it 20 20? Doesn't matter what I make that 1. No. So I borrowed 1. I can make it anything I want to, right? Well, we just said, what's our rule for adding and subtracting fractions? Common denominator. So I'm going to look at my denominator. What's my denominator? So what am I going to make that 1 I just borrowed? 3/3. Correct? So really what I'm doing is I'm taking the 3/3 I borrowed from 1 and I'm adding the 1/3. So the easy way to do this, I just add the numerator and denominator together. So I take 3 plus 1 and I get. So that gives me my new numerator. If you need to visualize that, you could say, okay, that's 3/3 plus 1/3, which is really what I'm doing. Now my numerator is larger. Can I do 4 minus 2?
Yeah.
Yes. So I've done the fraction piece. Now, once I've done the fraction portion, I add and subtract the whole numbers. So this works for both addition and subtraction. So now my whole number now is a 3 because I had to borrow. 3 minus 1 gives me 2, and then I put it back together with the fraction. So 2 and 2/3. That was a terrible 2/3. That makes sense for everybody.
Yeah.
Okay, here's option 2. This is Ms. McShann's preferred method. In her method, we'll use the same number so you can see it's 4 1/3 minus 1 2/3. Find a common denominator for the fraction. Again, I need to focus in on the fractions, get my common denominator. Once I have a common denominator, now I need to turn both mixed numbers into improper fractions. That is where our whole slam dunk comes in. You guys remember that now? So I'm going to multiply, because I go fast in the first part of the slam dunk and then slow. Multiply, then add. So 3 times 4 is 12 plus 1 is 13/3. 2 times 1 is, or 3 times 1 plus 2, 5/3. Now I just do the math. 13 minus 5 gives me 8. So now I add subtract the numerator. Sorry, I forgot to put that part in there. I did it. We didn't write it. So once I have the improper fractions, I'm just going to add and subtract the numerators. But now we need to simplify. Notice we didn't have that in the other one, right? Because it actually came out in simple form. So here's where your math could get considerably harder. How many times is 3 going to go into 8? 2. With how much left over?
2.
Did I get the same answer? Yes. Did I use either method? Yes. Okay. I'll be honest. Number one is going to take you some practice, but it's a lot easier once you understand it. Number two is always going to work. Okay. So there's advantages to both. Okay. At this point, I need everybody to take your packet and go to the last page. It says reciprocals on top. The last page of the packet on top. The packet we gave you. Okay. Reciprocal. Bracket operation. Okay, let's start with what are reciprocals?
The opposite of a fraction when the flipped over.
Flipped over piece of a fraction. So our technical definition is two numbers that equal 1 when you multiply them together. So if I multiply two numbers and equals 1, those are what we call reciprocals. Mason gave us how that happens. So for example, if I have a number like 3, but I need the reciprocal, I need to turn 3 into an improper fraction. How do I turn the whole number into an improper fraction? Put it over 1. So now that I have that, I can do what Mason told us to do, which is flip it. So to flip that, that becomes 1 over 3. To see that they are reciprocals, I now multiply them. What is 3 times 1? 3. What's 1 times 3? What is 3 over 3? 1. So those numbers are reciprocals. Does that make sense? Okay. Do mixed numbers have reciprocals? Yes, they do. The key is I need to slam dunk. I need to make them improper fractions first. So yes, they do, but you need to make them improper fractions first. Okay? So that'll be our whole slam dunk process. Remember, it goes fast, multiply the denominator times the whole number, and then as it goes slow, we add in the numerator. So let's just take a quick look at what we're going to be doing on this back page for at least the top part. What is the reciprocal of 3/4? 4/3. How do I check that? I go and I look at my definition. I say, okay, well, I have 3/4 and I multiply by 4/3. 3 times 4 is 12. 4 times 3 is 12. 12 over 12 is 1. Check the reciprocal. Make sense? Okay. Just as a review, if it's a whole number, how do I make it an improper fraction? Add 1 over it, then you find your reciprocal. If it's a mixed number, how do I make it an improper fraction? Slam dunk. So I'm going to multiply, then add. It gives me 54 plus 4, so that's 58 over 9. And then for my reciprocal, what am I going to do to that? Flip it. Then I multiply to check to make sure it equals 1. Questions on what we are doing? Okay, you guys have the rest of the class to work on the rest of the packet. And then you don't get finished, will become your homework. You have to see someone actually finish the packet in class. I'm worried about that today. Okay, good luck, guys.